All right, so I have my beta glycosidic bond here and a lactose. And this is the part that's kind of hard to model to illustrate, but see how close the carbon is here to my oxygen that's in my glycosidic bond. There's also hydrogens on that carbon that can be very, very close to that oxygen. So it's kind of hindered. It's hard to break this bond down. But if you had the right enzymes in your body, you could take this ring, right? So it's got a certain orientation. I already have it kind of goofy right now because that carbon was down, but it's that chair-like orientation we talked about before. If I flip it so that this, excuse me, I have to kind of video this and hold both my phone and this at the same time. If I flip this oxygen up and then I flip this carbon down, right, in that ring, if I rotate that down so that the chair is sitting different, see how that oxygen's not nearly as close to that carbon anymore? And that's actually kind of a big deal, right? Now this could be relatively easy for you to break down this bond, right? This glycosidic bond. But sometimes you need an enzyme to help you do that. Because if the conformation of my chair is different, I'm trying to flip it back one-handed and I'm not real talented, right? Then that carbon gets really, really close again. So again, it depends on the person, but you have proteins that will help you, enzymes that help you orient this correctly so it'd be a lot easier to get to that bond and break it down. And if you're lactose intolerant, you don't have those proteins.